Just a few top tips for you for the F324 exam. Apologies if you've seen the F322 ones. I've reused some of the slides because the mistakes are often the same. So in mechanisms, the curly arrows show the movement of an electron pair, so you must start them from bonds, not atoms, or if it's a benzene mechanism, from the delocalized electron cloud. Curly arrows from a minus sign or a lone pair of a nucleophile. Example, the H-, the hydride ion. Spelling, it's electrophilic, not electrophilic, and the same for nucleophilic. EZ isomers, base your diagram on an ethene molecule. That makes it easier for you to show the relative positions of the groups. So if they're both up there at Z, if they're across the bond like that, diagonally opposite, it's E. Trans fats. So they're E isomers of fatty acids, and they raise levels of bad cholesterol, not just cholesterol, because you can get good cholesterol as well. Repeat units, don't forget about these end bonds. They must poke through the brackets. It shows the continuation of the molecule. State symbols, if it asks for them, write them. Significant figures, double check, triple check. Units, moles are calculated using grams. Just be careful if they give you masses in kilos, milligrams, tons, etc. Must convert to grams. If the question says include equations in your answer, include them. Hydrolysis, reflux with an aqueous acid or an aqueous alkali. You must reference water. Diazonium ions, the positive charge is on that first nitrogen. So you could write it like this. You can even write it like that, but that would be marked wrong. If it says diazonium compound, write the formula of the diazonium compound or the compound formed. These aren't ions anymore, and so you need to include the negative ion too. So if the negative ion was a Cl- ion, which it often is, it would be something like this or something like this. Carboxylate salts, COO- Na+, or COONA. Just be careful. That looks like that is a covalent bond, and it will be marked wrong. Zwitter ions, you take the H+ from the COOH, so this one here, and you put it over there. So that will become COO-, that will become NH3+. Be careful if there's one of these groups in the R group, that stays for the Zwitter ion, because Zwitter ions have no overall charge. Mass spec, don't forget the positive charge on all of your formulae. So every peak on a mass spectrum is caused by a positive ion. And remember, the peak furthest to the right, not the biggest peak, is the molecular ion peak, and that tells you the MR. IR spec, annotate your spectra. So I've just written there, that's an OH. It's actually the OH of a COOH group because it's in the right region for that. There's a C double bond O, and so therefore this molecule must contain the COOH. If you don't get a broad absorption around here, remember the alcohol one's a bit further to the left, you could say molecule does not contain an OH group. NMR spec, again, annotate your spectra. So I'm looking at this signal here. So you would say something like this. You could write this on the spectrum. Signal at delta 3.7 ppm means the H's given the signal are in this environment. It's a quartet, and so far these H's are adjacent to a CH3 group. The peak area is 2, red number there. Therefore, there are 2 H's in the environment, and that helps you build up the molecule. And remember, this peak at 0, which is sometimes shown, is the TMS peak, and TMS is used to provide the reference peak because it has that 0 ppm. That's it. So the very, very best of luck.